You've heard these words a million times, right? Hypothesis, theory. In everyday chat, we kind of toss them around like they mean the same thing. A hunch, an idea. But in the world of science, they're not just different. They're basically the starting line and the finish line of a huge discovery. So let's clear up the confusion once and for all. Okay, so let's start with a phrase that I guarantee every single one of us has used. You're trying to figure something out, you get that little spark of an idea, and you say, come on, who hasn't? You're trying to predict the ending of a TV show or figure out why your favorite team keeps fumbling the ball. It's just a natural way to say, I think I know what's going on here. But the real question is that actually a theory? Well, here's the thing. In the language of science, that brilliant idea, that really smart guess you just came up with, that's a hypothesis. And look, getting this right isn't about being a stickler for words. It's about understanding the fundamental ways science actually works. All right, so let's really zoom in on the hypothesis. This is the starting block. It's the launch pad for pretty much every major scientific breakthrough you can think of. It's that first, absolutely crucial step. The two magic words here are proposed and, even more importantly, testable. See, a hypothesis isn't a fact. It's an idea you're putting out there, and it has to be something you can actually test. You have to be able to design an experiment that will either prove it right or prove it wrong. Okay, that might still sound a little academic, right? So let's bring it down to earth, because you actually use this kind of thinking all the time without even realizing it. Imagine this scenario. Your car won't start. This right here is the scientific method in a nutshell. First, your observation. The car is dead. That leads you to a question. Maybe the battery died. And from that, you form a testable hypothesis. Okay, if the battery is dead, then using jumper cables will get it to start. The experiment is hooking up the cables. The result, the engine roars to life. And boom, you have your conclusion. Your hypothesis was spot on. It's a perfect, logical journey from a simple guess to a confirmed answer. So if a hypothesis is the starting line, what does the finish line even look like? What's the gold medal? Well, that is where we get to the scientific theory. This is the big one. Let me be super clear. A theory is not a guess. It's not a hunch. It's basically the exact opposite. A scientific theory is a powerful, massive explanation that's been tested again and again and again by countless scientists, and it is held up every single time. It has earned its title through some seriously tough testing. You know this phrase for sure. It's a fantastic little summary, but honestly, it's just the tiniest tip of a colossal iceberg for one of the most powerful and well-supported theories in the history of science. These are the heavy hitters, the pillars holding up our understanding of the universe. Evolution, the Big Bang, general relativity, these are not theories in the casual, I have a theory about this kind of way. No way. They are monumental frameworks that explain everything from why we have so many different kinds of life on this planet to the very fabric of space and time itself. Each one is built on a mountain of hard evidence. And just to give you a sense of scale, the Big Bang Theory helps explain the origin and evolution of our entire universe over 13.8 billion years. That's the kind of incredible explanatory power a real scientific theory brings to the table. It's so much more than a simple guess. All right, we've defined them, we've seen some examples. Now for the main event. Let's put them side by side, head to head. This is where it all clicks into place. Let's just break it all the way down. On one hand, a hypothesis is a specific, educated guess. It's untested, it's the starting point. On the other hand, a theory is a broad, powerful explanation that's already backed by tons of verified data. Here's a great way to think about it. A hypothesis is the question mark that starts the whole process. A theory is the exclamation point at the end of a long, successful investigation. So, why does any of this matter? Is it just about winning a vocabulary argument with your friends? Absolutely not. Understanding this difference is actually a super important skill for just navigating the world today. When you hear someone try to dismiss something really important by saying, oh, that's just a theory, you'll know they're completely missing the point of what a scientific theory even is. Knowing the difference empowers you. It helps you appreciate the incredible hard work behind scientific knowledge, and frankly, it helps you spot misinformation from a mile away. So I'll leave you with this little thought experiment. Every single one of those giant theories we talked about started out as a humble little hypothesis. And right now, today, scientists are testing new hypotheses that could one day become the bedrock science of the future, thinking about which ones might make that incredible